Okay, so with 4.1.2, we will be looking at square roots. Chapter 4 is only quadratics, so we're only doing square roots right now. We'll simplify by doing prime factor trees. We'll add and subtract radicals, multiply. We'll do division and rationalization, and then we'll solve using square roots. It sounds like a lot, but to me, it does not seem like a lot. When we get to chapter 6, that's when we're going to do more than just a square root. You'll get some of the same concepts, but with cube root or maybe fourth root. Okay, so we're only focused on square root now. When you are simplifying a radical, okay, you hopefully know your perfect squares and you can recognize them. But if not, remember you got your calculator, you can always check. You should always check for a perfect square first, and then when you're just simplifying, if it's not a perfect square, you do your prime factor tree. Okay, and then that should not be new because I know when y'all did special right triangles in geometry, I know you have radicals in that, and I also know you have to rationalize. So this shouldn't be that difficult. If I am just telling you to simplify square root of 176, is the square root of 176 a perfect square? No. So then what I'm going to do is take that 176 and do my prime factor tree. So if I can split that, I can divide that into 2 and get what? 176 divided by 2 would be 88. And then 88, I could split 2 and 44. 44 splits 2 and then that is 2 and 11. And since it's square roots, you want 2 of the same number. So I've got 2 pairs of 2 that I'm going to circle. And then whatever is left over, I box. You don't have to, but I do that to draw attention that it doesn't just get stuck in the tree and you forget about it. Okay, so I circle my pairs and box my leftovers. So each paired factor, you only write that one number. So I'm going to have 2 and then another 2 that I multiply square root of that 11 that's left over. So that gives me 4 square root of 11. Y'all remember doing this?
Yeah.
So if I have a coefficient in front, I just have to consider that whenever I am taking out my factors that I paired. Okay, so if I have 2 square root of 12, 12 will split 2 and 6, and then 6 splits 2 and 3. So I have a pair of 2s with a 3 left over. But I have to also bring down the 2 that's already part of my problem. So I'm going to multiply that 2 that was already there by the 2 that I pulled out, and then square root of 3 is left over. So that's going to give me 4 square root of 3. And if you wanted to, you could check your answer. You could type your original, which is just 2 square root of 12. And then you could type 4 square root of 3, and it will give you the same decimal. Okay, so that's a way to check it. So if I do negative 5 square root of 27, what do? How do I start that problem? I do my 27. What does it split? And then 9 splits. So I can pair a set of 3 with 1 left over. What would my full answer be? Okay, so you can take that negative 5 times 3 square root of 3. And my final answer, negative 15 square root of 3. Not bad. Okay. When we move to adding and subtracting, you can only add and subtract like radicals. So they have to be the same number under the radical, which is called the radicand. Okay. So if I have 2 square root of 3 plus 3 square root of 2, that's like me trying to add 2x plus 3y. They're not like terms, you can't do it. Okay. If they are like terms, then all you're doing is adding your coefficients. Just like if I had 2x plus 5x, that would give me 7x. I did not change that variable. So when I'm doing radicals, the radical does not change, only the coefficients. So 2 square root of 3 plus 5 square root of 3, I'm only doing coefficients to get 7. That square root of 3 stays. Okay. Now, hardly ever is it going to be set up for you. Okay, so you're going to look at more problems that you have to simplify first. Okay, so if I have negative 5 square root of 2 plus square root of 18, those are not like radicals, but I can simplify the square root of 18. If I do that, that will split 2 and 9, and 9 splits 3 and 3. So I have a pair of 3 with a 2 left over. So I bring down my negative 5 square root of 2 plus square root of 18 simplifies to 3 square root of 2. Now they're like terms. Now I can combine them and my answer would be what?
Negative 2 square root of 2.
Negative 2 square root of 2. Okay? So if I have 3 terms, I'm still going to see if I can simplify. Okay, so if I have 2 square root of 8, I can simplify the square root of 8. That breaks into 2 and 4. 4 breaks 2 and 2. So I have a pair of 2's with a 2 left over. I also have the 2 out front. So 2 square root of 8 simplifies to what? 4 square root of 2 plus 5 square root of 2 minus 4 square root of 3. Okay. Now I can combine 4 square root of 2 plus 5 square root of 2 to become 9 square root of 2, but that negative 4 square root of 3 cannot combine with anything, so I just bring it down. There are 2 properties that we're going to look at with multiplying and dividing. If you take 2 radicals and multiply them, it does not matter what is underneath the radical. They do not have to be the same. When you're multiplying, you can multiply anything and it will just become under the radical. So if I had square root of 2 times square root of 6, I could multiply that square root of 12. Okay? If you're dividing, if you have a fraction, that means division. All this is telling you, if you have the square root of a fraction, you can just separate the radical square root of your numerator over square root of your denominator. And that's it. Okay? So with multiplying, you're going to do outside times outside, radical times radical. You don't want to mix. If I have a constant times a radical, you're not going to multiply those 2 numbers together. So, for instance, if I had 2 times x, that just becomes 2x. Okay, so same thing, if I had 2 times a radical, say square root of 3, that just becomes 2 square root of 3, not square root of 6. Okay, so outside stays outside, radical can multiply by radical. Okay, so if I have 2 square root of 3 times 6 square root of 6, I'm going to multiply outside times outside, so 2 times 6 is 12. And then radical times radical, that square root of 3 times square root of 6 would give me the square root of 18. Y'all follow me? Okay. So then I simplify. If I can take 18 and break it, that gives me 2 and 9, 3 and 3. 3 square root of 2. If you know what it should become, you don't have to do the prime factor tree every single problem. If it's one that you use over and over and you automatically know square root of 8 is 2 square root of 2, that's fine. You don't have to, I'm not going to count off for not showing me this. This is your side work that you need to get your answer. Okay? So here, this is 3 square root of 2, but I also have a 12. So 12 times 3 square root of 2 is going to give me 36 square root of 2. And you can still check these the same way. The whole worksheet you could check. You could type your original, type your answer, make sure it gives you the same value. Okay? If I take 5 square root of 7 and square it, that means I'm taking 5 square root of 7 times 5 square root of 7. Once you write it twice, you're back to what we just did. Outside times outside is going to give me what?
25.
25. Square root of 7 times square root of 7 gives me
49.
square root of 49. But what do we know about the square root of 49?
Square.
It's a perfect square. It's 7. So this is just 25 times 7. When it's a perfect square, it's a common mistake. Y'all are in the habit of just rewriting a radical, and people will give me the square root of 7. Try not to do that. It's just 25 times 7. And then that will give you the final answer of what?
175.
Okay. Now, when you have a number in front of the set of parentheses, you all know that you should be distributing. So you're going to do the same thing, but now with a radical. So square root of 3 times 2 square root of 2, then square root of 3 times 4 square root of 6. Now, this is just a radical. So if I'm looking at what's inside my parentheses, is the 2 coefficient and the 4 coefficient going to change? No, because I don't have a coefficient in front of the square root of 3 to multiply them by. So the only things that are going to change are my radicals. Okay, so square root of 3 times 2 square root of 2 is going to give me 2 square root of 6. And then square root of 3 times 4 square root of 6 is going to give me 4 square root of 18. And then you simplify. 2 square root of 6 won't simplify. But square root of 18, we've already done, is 3 square root of 2. So 4 square root of 18 becomes what? 12 square root of 2. Can I combine those? No. So even though it looks weird, that's my answer. The order doesn't matter with radicals as long as it's all there. Okay? Now, when we have 6 plus square root of 3 squared, I have to write that twice. 6 plus square root of 3 times 6 plus square root of 3. And then, what do I do with that? What do you typically do when you write it twice? You FOIL it. So I'm going to take 6 times 6, and that is 36. 6 times square root of 3. I have a constant times a radical.
6 square root of 3.
You just combine it to be 6 square root of 3. And then again, I've got square root of 3 times 6. So that's another 6 square root of 3. And then I have square root of 3 times square root of 3, which is square root of 9. What can we do from there? Okay, I could combine 6 square root of 3 and 6 square root of 3. Is there anything else I could do? Square root of 9 is a perfect square. That's just the 3. So, can I combine 36 with the 3?
Yes.
That gives me 39 plus what?
12 square root of 6.
12 square root of 3. Okay. Now, with this next problem, you're still FOILing, but you have a radical on each term. This can get messy, and this is usually the one where people will make mistakes. If you are a visual person and that is a lot to you, you can always take 2 different colors, highlight your coefficients with one color and your radicals with another, and then you only multiply like colors, because those are your like terms. Okay. You don't have to do that, but if it's a lot for you to look at and you struggle with that concept, the highlighters might help you. Okay. So when I multiply 3 square root of 6 times 2 square root of 2, I'm going to cover up what I'm not looking at. 3 square root of 6 times 2 square root of 2, what will that give me?
6 square root of
6 square root of 12.
Very good. And then 3 square root of 6 times square root of 3.
3 square root of 18.
Very good. And then I have 4 square root of 7 times 2 square root of 2.
8 square root of 14.
Good. Plus 4 square root of 7 times square root of 3.
4 square root of 7.
Y'all okay with that? Okay. So then I need to simplify. 6 square root of 12 can be simplified. 12 can break 2 and 6, 2 and 3. So I have a pair of 2 with a 3 left over. So that whole term, 6 square root of 12, simplifies to what?
12 square root of 3.
12 square root of 3. Plus, we know the square root of 18 is 3 square root of 2. So 3 square root of 18 becomes what?
9 square root of 2.
9 square root of 2. Can I break 8 square root of 14? No, because it's just 2 and 7. Nothing will pair. I leave that. What about 4 square root of 21? That's going to be 3 and 7, so that's got to stay as well. So even though I can't combine anything, this is going to be my simplified answer. Okay, we did so far. All right. When I have my fractions, okay, I'm going to check to see if the fraction underneath the radical can be reduced, because I always want to work with smaller numbers as I can. Okay, so if I'm looking, can 2 over 25 be reduced? No. If it were something like 5 over 25, then I could. But 2 over 25, I cannot. So if I can't, then what I'm going to do is I'm going to split that radical and have square root of 2 over the square root of 25. And then I check for perfect squares. Okay, so I can't do anything with the square root of 2. But I can take the square root of 25, and that is 5. Now, the only thing, once you do that, the only thing to check for is if you have a radical in the denominator, which I do not, because it's a perfect square, so that's all I have to do. But they're not all going to be like that. You might have one. Okay? So if I'm looking at the next example, square root of 5 halves, I cannot simplify 5 halves, so I separate square root of 5 and square root of 2. I don't have any perfect squares, but I do have a radical in the denominator, which is mathematically like against the rules. So, how could I get rid of the square root of 2? You rationalize, you multiply by the square root of 2. So what we were doing earlier, when we had square root of 7 times square root of 7, gave us square root of 49, which is ultimately just 7. And then square root of 3 times square root of 3 ultimately gave us 3. So this concept, rationalization, you're going to multiply it by itself because you want to undo that radical. This will give me the square root of 4, which is just 2. When you are rationalizing, you multiply by itself, it just leaves you with the number under the radical. You should not have to do the middle part of telling me square root of 4. Okay, I want you to be able to go straight from this to the 2. So even if you had square root of 100 times square root of 100, just leave me with 100. Okay, don't do the middle part of that. So now, like obviously show me what you're multiplying by, but you don't have to show me what that denominator is before you simplify. Okay, and then my numerator, square root of 5 times square root of 2 is square root of 10. After that, you see if you can simplify anything. I cannot, because I have a radical and my denominator is not, so those are not technically like terms to simplify. Okay? So when I look at my next one, I've got the square root of 9 over 8. I simplify square root of 9 over the square root of 8 because I can't simplify 9 over 8. But I can simplify square root of 9, and that is 3. Can I simplify the square root of 8? Yeah, that is 2 square root of 2 because 8 splits 2 and 4. 4 is 2 and 2. Okay, I like to simplify first because I like to rationalize the smaller numbers. Okay, so here, the 2 square root of 2 is not the problem. The only problem is the square root of 2. So to get rid of it, I do not multiply 2 square root of 2, I only multiply by square root of 2. You should only be rationalizing by a radical, not a constant with it. So then my numerator becomes 3 square root of 2. My denominator, I already had a 2 out front, and then I'm multiplying that by the 2 I get with rationalizing. So this is going to be 3 square root of 2 over 4. Okay. Any have questions? Okay. So if I have the square root of 17 over 12, does that simplify? Can I simplify 17 over 12 as a fraction? No, because 17 is prime. So I'm going to split square root of 17. Can I simplify the square root of 12? What does it become? 2 square root of 3. So then what would I have to do?
Multiply by
Multiply by
square root of 2.
Multiply by the square root of 3. Good. And what's my answer? Not 2
Over 6.
over 6. Because you have the square root of 3 times square root of 3 is 3. Times the 2 that's already there gives you your 6. So square root of 51 over 6. Y'all good? Do we have questions? Okay, I want you to try and apply all of that to the next example. Are we ready?
Yes.
What's your first step?
Times square root of 10.
I didn't hear you.
Times square root of 10.
Oh, you multiplied by the square root of 10. Did anyone do something else? Y'all multiplied by the square root of 10? Did anyone recognize that you could simplify
Right then.
Yes.
this?
Right
Yes.
Okay, so that's why I kept emphasizing you can't simplify 9 over 8. You can't simplify this. You could simplify this because they're both radical. It's not wrong if you didn't, so don't erase it. You'll get the same answer, okay? But if I were doing it, I would see 2 square root of 6 over 5 square root of 10. 6 and 10 simplify to So 2 square root of 3 and 5 square root of 5. You can do that because they're both radicals. Okay, so then I would only need to rationalize by the square root of 5, and that gives me 2 square root of 15 over 25, which if you multiply by the square root of 10, you'd have 2 square root of 60 over 50. Simplify your 60, you get 4 square root of 15 over 50, simplify to this. So either way you get the same answer. Okay? You just have larger numbers if you don't simplify at the beginning.
Let's go.
Okay, are we good with this section? Okay. Okay, now I've got what looks totally different, but it's really not different. The only thing is I had one term in my numerator. Now I have two. I still look at the same thing. I can't have a radical in the denominator. So I'm going to rationalize by the square root of 3 over the square root of 3. Now that I have more terms in my numerator, I've got to distribute the square root of 3 to 3 and the square root of 3 to negative 2 square root of 2. Y'all follow me? You're multiplying two terms with one, so you distribute that. Okay, so then 3 times the square root of 3 is 3 square root of 3. And negative 2 square root of 2 times square root of 3 is a negative 2 square root of 6. And then my denominator becomes what? 12. Because you have your 4 times your 3. Then you would see, can I simplify the 3, the 2, and the 12 by the same thing? I cannot. So this is my answer. I can't simplify square root of 6. I can't simplify 3, so that's all I can do. Okay. Now this next one, 10 plus 5 square root of 2 over 6 square root of 5, I want you to walk me through it. Without any prompting.
Multiply by square root of 5.
Okay. Distribute. What's my first term?
10 square root of 5.
Okay.
5 square root of 10.
All right. Over what?
30. Well, these things are
Okay, so they can all three be simplified by 5. 10, 5, and 30 can be divided by 5. So my final answer would be what?
2 square root of 5 plus square root of 10 over 6.
Now, I will tell you, if you're typing your original and you type this one and you don't catch that you have to simplify, this will still be the same value. So you're on the right path, it's just not fully simplified. Okay? Are we good with that? With just rationalizing one? Okay? Now, if we look at, hold on for that one. If we look at this, now we've got two terms in the denominator instead of just one. Okay? So when you have a binomial, two terms separated with a plus or minus, then you're going to have to use the conjugate to rationalize. So a conjugate is just, say you have a plus b, so x plus 3. Its conjugate is the exact same thing, just with a minus. Okay, so x plus 3 and x minus 3 are conjugates. What do you also recognize about those two? Last class, I would have given you this, and you would have factored this, right? Okay, so the difference of two squares occurs because your conjugate's nature is to always cancel that middle term. If I were to FOIL this, this would give me x squared minus 3x plus 3x minus 9. A conjugate's purpose is to cancel that middle, leaving you with just the first term squared minus the second term squared. Okay, so at this point, I'm expecting you to recognize that it's a conjugate and go straight to that formula, not FOIL. Okay, so my formula, regardless of if I have variables and whole numbers or radicals, if you have a plus b and a minus b, all you're doing is taking your first term and squaring minus, it will always be minus, your second term squared. So whether it's like x plus 3, x minus 3, or you actually have radicals, it's still going to be first term squared minus second term squared. Okay? So if I'm looking at 3 plus square root of 2 times 3 minus square root of 2, I shouldn't have to FOIL that. I recognize it's the exact same thing. One's a plus, one's a minus. So I take the first term squared. So 3 squared is 9. Minus second term squared. Square root of 2 squared is just 2.
2.
What's 9 minus 2?
7.
7. Notice that I no longer have a radical. Okay? Again, the reason is if I FOILed it, the radical would be those two middle terms that cancel. Okay? So that is why we use the conjugate to rationalize. If all I did on this problem was multiply by the square root of 5, I would distribute that and I would have a 7 square root of 5. Again, I can't have a radical in the denominator. So you can't just do what we've been doing at this point with the binomial in the denominator. At that point, you've got to multiply by the conjugate. So if I start with 7 minus square root of 5, its conjugate would be what?
7 plus 4.
7 plus square root of 5. You just change the sign in the middle. That is the only way that that radical will cancel in the denominator. Okay? So in my numerator, I distribute the negative 6. And what does my numerator become? Negative 42. Then negative 6 times square root of 5 is negative 6 square root of 5. Okay? And then my denominator, they're conjugates, so I take my first term and square it. So 7 squared is
49.
49. Minus square root of 5 squared is. So I clean it up. Negative 42 minus 6 square root of 5 over
2.
49 minus 5 is 44. Can I do anything else? I can simplify, right? I've got a negative 42, a negative 6, and a 44. What can I divide those by?
2.
2, and it becomes
Negative 21.
Minus 3 square root of 5.
5 over.
mhm. Okay. So now if I have 3 over 7 plus square root of 2, I can multiply by what?
7 minus square root of 2.
7 minus square root of 2 is its conjugate. So my numerator, I'm distributing 3 times 7 to get 21, and 3 times negative square root of 2 is a negative.
3.
Very good. And then my denominator, I take my first term and square it, which is 49. And then my second term and square it would be minus 2. So that's 21 minus 3 square root of 2 over 47. Can I do anything further with that? No, I cannot. But this is easy. Okay. I want you to try to do the next one. What did we multiply by?
2 minus square root of 5.
Okay. You had to FOIL the numerator.
Yeah.
Okay. So 7 times 2 should have given you
14.
7 times negative square root of 5.
Negative 7 square root of 5.
Okay. Negative 2 square root of 5 times 2.
Negative 4 square root of 5.
And then negative 2 square root of 5 times negative square root of 5.
Negative 2 times 2 square root of 25.
Okay.
Is it positive?
So you have a negative times a negative, so it is positive. And then you've got your 2, and then square root of 5 times square root of 5 is 5. So 2 times 5 is 10. If you have 2 square root of 25 and you change it to 5 and then you change it to 10, that's fine. You can do steps in the middle. You don't have to go straight to 10 if you don't see it. As long as you get there. Okay? And then my denominator should be what?
Negative 1.
Before you get negative 1.
4 minus 5.
4 minus 5. Okay? Are we okay so far?
Yes.
Do we have questions on how we got the numerator? Okay. So then when I combine my like terms, 14 plus 10 is 24. Negative 7 squared root of 5 minus 4 squared root of 5 gives me
Negative
over
negative
negative 1. Should I leave it like that?
Wait.
Apparently not.
You can't have a negative.
I should. Okay, would you ever leave something for starters like this? If it were just a positive one, would you ever leave it like that?
No, so we can just make it a negative 24, right?
No.
No.
Say it louder.
We can make it a negative 24 plus 11 square root of 5.
Yes. Okay. 1, you can't have a negative in the denominator. And all that is a negative 1, so just divide everything by negative 1.
Go. Yeah.
Okay, you want to try the next one on your own?
Yes.
Okay. What do you multiply by? 1 plus 2 squared root of 6. So when you FOIL the numerator, 4 times 1 gives you 4 times 2 squared root of 6. Negative 3 squared root of 6 times 1. And then negative 3 squared root of 6 times 2 squared root of 6.
Negative 36.
Because you have negative 3 times 2, which is a negative 6. And then square root of 6 times square root of 6 is your 6. So did y'all catch it this time? Even though you might not have caught the 10? Okay. Now my denominator, you take the first term and square it, which is 1, minus, what'd you get here?
12.
So usually I either get a 12 or a 24. Which one's correct? So look at what you're multiplying. You're doing 2 square root of 6 squared, right? So that means 2 square root of 6 times 2 square root of 6. 2 times 2 is 4. Square root of 6 times square root of 6 is 6. So 24 is the correct one. Okay. So then, combine like terms. 4 minus 36 is a negative 32. Plus over.
Negative 23.
Okay. I can't simplify those, but I have a negative in the denominator.
Negative 1.
I've got to take care of this negative. So I'm essentially either multiplying or dividing by a negative 1 for each one. So all that happens is everything changes signs. So it becomes a positive 32 minus 5 square root of 6 over a positive 23. Okay. So when you're rationalizing with a conjugate, take your time when you multiply. It's okay to need to do the extra work on the side. Okay? Questions on that section? Okay. When we get to solving using square roots, so up until this point we were just simplifying. Okay? When you actually solve, you're solving for your x squared like you would an x. All your basic inverse operations. Okay, so if I have 3x squared plus 5 equals 41, I want the x squared by itself. What would I get rid of first? The 5. I would subtract 5, so 3x squared is equal to 41 minus 5 leaves me with 36. Then what do you need to do? Not yet. Divide by 3. X squared is equal to 12. You can't square root until x squared is by itself. Then you take the square root. X is equal to, so remember last class we did this, and what did I say? Every time you take the square root, you have plus or minus because you have a positive solution and a negative solution. Now the square root of 12 can simplify. That simplifies
2 squared root of 3.
2 square root of 3. Now that I'm actually solving and getting x values and getting solutions, that's why you have a plus and minus here. Simplifying, you cannot. So make sure you know what you're doing when. Okay. Now, if I have, instead of parentheses, instead of just an x squared, I have parentheses squared. That's what I want. Whatever is being squared, I want by itself because I'm going to have to end up taking the square root at some point. So I need that isolated first. Okay, so I do not write it twice. I do not FOIL it. I do not distribute. I want everything away from that. Okay, so I will divide both sides by 3. And that will leave me with x minus 2 squared equals 40/3. I do not do decimals unless I give you a decimal in the problem and no mixed numbers. Okay, so when I go and square root this, I'm square rooting a fraction. So I have my x minus 2 that's left by itself. I have my plus and minus. When I take this square root of a fraction, I'm doing what I just did in the page before. Okay, I've got the square root of 40 over the square root of 3. Can I simplify anything there? I can simplify square root of 40. 40 will split into 2 and 20, 2 and 10, and 2 and 5. So I have a pair of 2's with a 2 and a 5 left over. So that is 2 square root of 10 over square root of 3. Follow me? What's wrong with this? I have a square root in the denominator, so I need to multiply by the square root of 3. So that will give me 2 square root of 30 over 3. Okay. Now I want x by itself. I got rid of the squared portion. Now I want x by itself. What do I need to do? I need to move this 2 over. When you move the 2 over, you're going to add 2, and it's always going to go in front of the plus and minus. So you have your constant plus and minus your radical portion. Okay? So I've got x equals a positive 2 plus or minus 2 square root of 30 over 3. Okay? So don't box it. Before y'all get y'all's highlighter, don't box it. This is like saying x equals 2 plus 1/3. Would you ever leave your answer 2 plus 1/3? No. That's improper because you could combine those. Y'all have a calculator, you would type it in a calculator, but it's not that simple with this. Okay, so I'm doing this example so you get the concept, then we're going to apply it here. Okay, if I had 2 plus 1/3, I can't add these. What would I have to do? I would have to manipulate my whole number and make it a fraction, right? So if I want it to be a fraction for me to add 1/3, what do I need this denominator to be? I need common denominators of 3. So what divided by 3 would be equivalent to 2? 6. Y'all all understand that, right? Y'all understand how 2 became 6 over 3. Now I would be able to add them and get a number or a fraction. So the same thing is happening here. I've got a whole number with a fraction. I want this to have a denominator of 3. If this were a 5, I would want this to be a 5. If it were 2, I would want it to be a 2. You want a common denominator so you can write it as one big fraction. Okay? What divided by 3 is equivalent to 2? 6. Now they're common denominators. The way you write your answer is your numerator 6 plus or minus 2 square root of 30 all over that 1/3. Okay, so all you're doing is you make that whole number a fraction with the common denominators combined as one. Okay, do we understand that? Okay. I'm going to give you another example to do that because if I only give you this, I don't trust that you're super confident in that if it were to pop up again. Okay, so if I have 2/5 times x plus 3 squared equals 5, I want what by itself? X plus 3 squared. So what do I need to do? I didn't honestly, I can't say I understood anything because y'all all said something, but not loud enough for me to hear. So I'm gonna tell you multiply by 5/2.
Go.
Okay, we're not gonna divide by fraction, we multiply by the reciprocal. And so that leaves me with x plus 3 squared equals, what's 5 times 5/2? 25 over 2. Then what do?
Square root.
Square root it. That cancels the squared, leaving me with x plus 3. I took the square root of a fraction, so it's square root of 25 over the square root of 2.
Square root.
So 5 over square root of 2. Multiply by square root of 2. So it becomes
Square root over 2. Subtract 3.
So I'm going to move my 3 by subtracting, so x equals negative 30 plus or minus 5 square root of 2 over 2. But I can't leave it like that. So I want that negative 3 to have what denominator?
2.
2. So
6.
what divided by 2 gives me negative 3?
Negative 6.
Negative 6. So now my final answer would be negative 6 plus or minus 5 square root of 2 all over 2. Okay? We understand putting it as one fraction? Okay, they're not all going to be like that. Okay? So this next example, I've got 3 times x plus 5 equals 32. What should I do first?
Minus
Okay? Subtract your 5 because I want what by itself?
5. X plus 2 squared.
X plus 2 squared. So I've got 3 times x plus 2 squared equals 27. Divide by 3, and x plus 2 squared equals 9.
Square root.
Take the square root to undo the squares. That leaves you with x plus 2 equals plus or minus 3.
Minus
I'm going to move my 2 over, and I get x equals negative 2 plus or minus 3. What does negative 2 plus or minus 3 really mean? So here I had a radical. Here I had radicals. I don't have a radical here. So you're not going to leave it like that. You're going to split x equals negative 2 plus 3 and x equals negative 2 minus 3. You're going to split the plus and minus and find your 2 actual answers. Okay, so when you have a perfect square, you're going to actually work it out and get your 2 specific values. So this is going to be x equals 1 and x equals negative 5. Y'all good with that?
This one.
Do we have questions?
No.
Okay,
Yes.
we do.
I'm just kidding.
Okay.
Just kidding.
Okay, so you're